Hello, we're back. And now we're going to talk about logarithmic functions. So it's very important that you can convert between logarithm and exponential functions. So if we look at our rule here, which is an equivalency, so we are just going to rewrite. Now, b cannot equal to 1, and b is also negative. If you notice it says a and b are positive real numbers. B is called the base of the logarithmic functions. Exponentials and logarithmic functions are inverses. So if you have the log form, y equals log x base b, that's equivalent to b to the y equals x. So here on number 1, 4 is your base. So 4 to the second equals 16. That's it. Well, because they're all numbers, we can say, does 4 to the second equal 16? Yes. So I rewrote it. Same thing here. The base is 5. And again, I like to think of smiling. 5 to the negative 1 is 0.2 or 0.2. So what we're trying to do is we are trying to just rewrite it in a different form. All right, write each equation in logarithmic form. So you write the word log. So number 3, your base is 2. You drop the 2. 16 is the answer. The answer goes here. And the 4 goes here. So again, if I check it by that smile, okay, 2 to the 4 is 16. I know I'm right. Same thing here. Log, base of the exponent is 27. Answer is 3 equals 1/3. Now, there are basic properties of logarithms. And I need to ask you to memorize all this. Starting here with how to change form. Log 1, any base, is 0. Now remember, we've already established the base cannot be 1 and it's also positive. Log b with a base b, where I call it the base match, is 1. And the reason is to the right in black. So the proof or the reason is given there. Log b, base b of x equals x, and b to the log x with the base b is x. So here, notice the 19 base of the exponent matches the 19 for the log of the argument. There's an understood 1. That's why we always get 1. Log 10. So when you see the word log, there's an understood 10 here. Again, notice your bases match. So that's 1. ln of e, ln is e. Okay, again, that's the understood base there. I wrote that a little bit large. So anytime you see ln, there's really a little e there. So that's 1. So kind of a side note, log 10 means, okay, not log 10, I should say log means the base is 10. ln means the base is e, which is like pi. It is a transcendental number, and it also has an approximation. Okay, log 1 any base, that's 273, is equal to 0. Okay, now we're going to move on. Okay. All right, simplify the expression. We are still simplifying. Again, you have a base match of 30 and 30. That's equal to 10. Notice the answer is the exponent. ln e, if you recall, ln is a understood base e. So that is negative 12. Number 10 is 10 to the log 14. Log having a base 10. And 8 to the log 8 of 5 equals 5. Now, when we graph logarithms, we have a restricted domain. Your x has to be greater than 0, or if it's a binomial or trinomial, we set it greater than 0 and solve. So basic logarithm, log x, is a domain of 0 to infinity, and you have a vertical asymptote every log. So it would be x equals 0. So if I'm going to graph it, the first thing I like to do is to graph my vertical asymptote. And then I can't pick -1 and I can't pick 0. So we're going to pick 1. Now I'm going to put this on the graphing calculator. And notice that the base here is 3. So on the calculator, we'll go ahead and look at what's called change of base. So you can do log of x divided by log of 3. So if I type in log x divided by log 3, I'm going to look at my table of values. I have an error at 0. Okay, I have a lot of decimals here. Okay, I'm going to double check this because if I have 3, I should get a 1. I don't have that. Okay, I forgot to close my parentheses. Make sure you close your parentheses. Now, why did I know that I should have gotten that 0? Because remember, you have a base match. Okay, log 1 is 0. 3 is 1. And then I'm scrolling through. 9 is 2. 1 is 0. 3 is 1. So you have the point 1, 0. 3, 1. And 9, 2. So again, curve it for me like this, and do not cross that vertical asymptote. It's not a horizontal line, but it gets closer and closer. We've talked about that. Okay, I would encourage you guys to solve these a little simpler if you have different bases by doing what's called change of base. I do log of 144 in parentheses divided by log of 12. Now we could also solve it, but if it's given in this, I just go ahead and type in log 144 divided by log 12. Now, in the next couple of lessons, we'll introduce some variables. So if it's whole numbers that meet our condition where the base is not 1 and it's greater than 0, we can just go ahead and do what's called change of base. So when you have the base as a number, and this is called the argument here, when the log term is also a number. Okay, that gives us to 1/2. All right, evaluate using your calculator. So again, this is practice. Notice it says round to 4 decimal places. So if we type in log 100, our answer is 2. So we just say 2. ln of e. Now, we can either type it in, or if I know this is a base match, my answer has to be -3. I'll go ahead and confirm it on the calculator. So you do ln, and your e is second ln. -3. I get -3. Okay, log of 200 is 2.3010299996, and I didn't follow directions, but I wanted you to see the number. So we want 4 decimal places. So if you count 1, 2, 3, 4, so you're rounding the zeros. So my answer is approximately 2.301, and because that's a 2, it stays a 0. Okay, now be careful. That's ln of 0.1243. And we get -2.08. 505728. Again, we want 4 decimal places right here. So here, the 5, I should have checked the 5 because I want the 0 there. If I'm looking at 5, 5 tells you to round up. So this answer is approximately, that was -2.0851. Okay, so that's it for those log rules. Please make sure you memorize those. You will need them not only for this class, and especially for the test 4 and the final, but also if you're moving on and you want to do business calculus, and other higher level math classes, you'll be expected to know this. Have a great day.